No, that's on me. Yeah.
We got about a minute. I'll wander over there. I'll start us from up there since it's working. Are you guys ready if I start us off here? Okay. Yep.
Yeah, we're ready.
Oh. All right. Welcome back to those of you on Zoom, as well as those of you in the room. I hope the break was enjoyable. Here, it was a little windy outside, but I saw many of us get out there and enjoy some Colorado sun. So we're about halfway through our presentations. We have 4 more for our Education Building Division this afternoon. First up is going to be our team from the University of Cincinnati. Before I wander back, Rick, can we confirm you can hear us okay and you're ready to go as well?
I'm ready and I can hear you. So
excellent. Thank you, Rick. Okay, I'm going to wander back. Give me just a second. To our team from the University of Cincinnati, why don't we give the slides one more check to make sure all of that functionality is still going.
And it's not working.
Try clicking in. Have you clicked in the Zoom?
There we go. I think got it.
Yep. Okay, so that's working. You're coming in loud and clear. That's fantastic. So just as a quick reminder, we'll have 8 minutes, which we will show a virtual 2-minute warning timer on the presenter's camera that's visible to you guys at the top of the Zoom screen. And then we'll have an opportunity for up to 15 minutes of Q&A. So with that, I'm going to hand it over to you guys and we will start as soon as you begin. So good luck.
All right, thank you. I'll go ahead and get started. Well, hello, I'm Paul from the University of Cincinnati. I'm here with my teammates, and this is our presentation for a net zero building in Córdoba, Argentina. So we had a multidisciplinary team of architecture, architectural engineering, and electrical engineering students. Our goals in the project, so in response to renewable energy initiatives in Argentina, we wanted to create a STEM-based vocational high school. Our site is in an underprivileged community, so it would benefit from an investment in education as well as sustainability. And we wanted to be conscious of local vernacular and be an integral part of the community. A little bit more about our site. It's located in central Argentina. The climate is classified as humid subtropical. They have mild temperatures year-round and receive a lot of sunshine. Our more immediate site context, it's located in a dense residential neighborhood. The site's a little bit less than an acre, and it currently serves as a park. Now to dive into our design. So like I mentioned previously, it's currently a park, and we wanted to be aware of community access and keep some of those aspects. We also were conscious of the height limitations. We didn't want to stick out, so being aware of that allowable volume, and we also wanted to be conscious of surrounding materials. In terms of programs, we had a clear organization. There was education wing on the east side to allow for light in the morning. The lobby is centrally located, and then on the west side, there is gathering space like the cafeteria and library. Some of our environmental strategies, since we're in the southern hemisphere, we wanted to hug the north end of the site. We had solar access on the trellis over on the roof, and then sawtooth roofs over the classrooms. We also had outdoor areas like a small soccer pitch, the park, and hybrid plazas. Some of the landscape strategies, we were aware of student circulation as well as integrating the community. We had outdoor rooms, and we were conscious of site views in the dense residential neighborhood. Taking a look at some of the plans, the first floor has a prominent centrally located lobby, which splits off into the gathering spaces, as well as the administrative and office spaces in the front. And then there's labs and collaboration spaces on the east side. On the second floor, there's classrooms and a mezzanine. And then on the third floor, there's a small soccer pitch. Taking a look at some of the passive design strategies, there's outdoor spaces, a south-facing clear story for indirect light, a sawtooth roof for solar access, and a thermal chimney that allows for natural ventilation. The classrooms are smaller, and there's lab spaces on the first floor for more alternate styles of learning. And then there's a trom wall on the north end of the site. And taking a better look at that trom wall, it's made of a perforated brick pattern that's in tune with a lot of the designs of the local vernacular, using bricks and CMUs. In the summer, to prevent overheating, the windows are operable and can open up, creating a breezy hybrid space. And in the winter, they can close and warm that corridor behind. And finally, taking a look at the occupant experience. There's easy access to HVAC and electrical equipment. There's a rooftop water harvesting system for rainwater management and landscape irrigation. There's a sawtooth roof system that blocks direct sun exposure and creates uniform light in the classrooms and is optimal for solar panels. There's an efficient lighting system to save energy with occupant sensors. As well as community spaces integrated, like the small soccer pitch and plazas and park access. And now I'm going to pass it off to my teammate, Peter.
Efficiency was the main priority of the building's design strategy when it came to heating and cooling the indoor environment and forming the structural system. The mechanical engineering design and strategies were formed around Cordova's moderate climate and the amount of sunlight exposure throughout the year. Given these challenges, an advanced heat pump system was designed in order to save energy, reduce the amount of harmful emissions from the building, and provide the occupant with a comfortable environment. The most efficient devices, including heat pumps, diffusers, and thermostats, were implemented to keep the energy usage down when filtering and circulating fresh outdoor air. The diagram here shows the level 2 main pipework along with mechanical ductwork design in each classroom. The structural system was informed by the local context, utilizing its similar features like brick veneers, load-bearing walls, and reinforced concrete beam systems. These structural diagrams show the buildup of the school using simple local materials. The first image is the concrete foundation in which the walls are formed on. The second image shows the concrete columns and beam systems on each floor. The west rooftop has a steel trellis wall system that forms on top of the columns in order to hold the solar devices. The third image displays the load-bearing interior and exterior walls. The walls are formed with concrete masonry units and are finished with a decorative brick veneer. Finally, the last image shows the exterior cladding, windows, and details that finalize the building and its structure. Now I'm going to pass it on to Vivian to talk about electricity and energy usage.
So this is a schematic one-line diagram to explain the distribution of electricity throughout the building. The PV arrays collect electricity. The charge controller monitors whether to send the power to the system or to the battery. The inverter transfers the electricity from DC to AC, and then the main distribution panel allocates power where it is needed. Now I'm going to talk about energy performance. Decisions throughout were made with a large focus on reducing energy usage and achieving net zero through energy performance. Examples of this would be the trom wall and the thermal chimney. This is a graph of the building's usage per week throughout the whole year. The darker orange is the usage, while the lighter orange shows the excess produced. The excess production allows the building to be completely net zero and run solely off of PV production. The total yearly usage is 129,778 kilowatt hours, which computes to an EUI of 15. To achieve net zero, 410 arrays at 340 watts are required. And then the total yearly energy usage created is 199,342 kilowatt hours per year. Thank Thank you. That concludes our presentation. Thank you for listening.
Wonderful. Thank you, guys. Thanks, students from the University of Cincinnati. Okay, we have now kind of an open 15 minutes of Q&A. You can retain control, of course, over the slides in case you would like to return to anything. So to our jurors, let's go ahead and open it up for questions to our student team from Ohio.
Kind of like to start it off. I really like your design using old school technologies such as, sawtooth roof and trauma wall. And I think that was great. What I was intrigued in, I have a question, is you're using a chiller to a chilled water tank, using that kind of as a battery storage to when the loop gets too hot, you bleed in some chilled water. So the delta T on that tank is pretty high. Is that an air cooled chiller, I assume?
Yes.
Yeah, so that's pretty clever. I like that. I was wondering, why would you use a chiller in combination with water source heat pump? But when you have excess power, weekends and such, I mean, that's a great idea. So anyway.
Yeah, there's definitely different climates and usage of water where we're going to be using more hot or cold at different times. So it's all about storing energy with that temperature and where we can transfer that hot water into cold to cool down or heat up certain systems.
Yeah. Is there any time when you're going to run with a chill water tank gets too hot? It doesn't look like it by your profile, but what happens if it does? Can you go to battery storage, or what is your fallback in the case the tank gets too hot?
In case, like I said, with the climate change, with the climate being kind of mild and everything, it wasn't the most crucial consideration, thing to take into consideration. We do have our energy battery storages that could be used to cool down certain tanks during seasons or times where the hot water storages are receiving too much energy or too much hot water coming in.
Anyway, I congratulate you. That was a great idea. So anyway, and so you can't tie to the grid, so you have to do clever things. So anyway, good job.
Thank you.
One more question. So how did you get hooked up to Argentina? So is this a real project?
I can take this. So we had our senior capstone tied with this, and our professor wanted to have us push our boundaries. And obviously we're not used to Argentinian climate, culture. So we had to do so much more research than if we picked a city in America. So it's just kind of pushing us to become better problem solvers.
I mean, of all the projects, I think this one is kind of ready to be designed and, without very much modification. So anyway, I really liked it. So thank you.
Thank you.
Thank you.
Yeah, I'd echo Rick's points. The research on culture and background is so important, and it was very, very clear that you did that from your narrative and then also from your presentation. So nice work. I guess the couple of questions I have are just about a couple of pieces of analysis. I was curious about whether you did daylight analysis, although conceptually you have everything right. So, you did a great job there. I was just curious if you actually studied it. And I was also curious about the embodied carbon, whether you studied the life cycle analysis of that.
You want to talk about the daylighting?
Well, we used Sapphira in pre-design for some initial daylighting and site-specific strategies. So yeah, we did do some research there.
And then also, I mean, the side that we're looking at is the north-facing side, which, if you think about it, it's our south-facing. It gets the most light, and so obviously these overhangs in this balcony and the trom wall all diffuse that extra harsh light, and the other sides have less harsh lighting. So that is pretty obvious in our that design. And then for the embodied carbon, so it wasn't something that I wanted to include in this presentation because I wanted to focus on the environmental performance, I mean, the energy performance. We looked into some things of using like more natural local bricks, that brick and CMU, because obviously that will reduce the transportation needs, and it also is supporting the local community. So in terms of the transportation, yeah, we thought about that and looked at that. And then the embodied carbon specifically, their bricks, I mean, some bricks can be reused, so that is an option, but we looked into some, yes.
Great. Yeah, thanks. Yeah, it's very clear that you address the daylighting aspect and that conceptually it is all there. And but yeah, just curious. Sometimes it is good to validate, even though you know what it's going to be. Sometimes it's good to run that just to kind of second check yourself. But yeah, great.
Yeah, thanks for asking about it.
Hi, Shannon here. Thank you guys. I noticed your analysis for the I think the couple of different HVAC systems you considered were comparing different electrical systems. So is this site not able to utilize gas, or was it more you wanted to electrify and try to maximize that solar reuse?
Well, the site was, the energy usages we were told to be completely off the grid. We asked eventually going in about natural gas and stuff like that, but when we decided the surface area of the roof and the amount of solar panel usage, we just said we should take advantage of this, especially if we're putting energy battery storages in. So we wanted to use electric devices and equipment as much as we could, not only for the energy saving part, but also to kind of keep it an in-house system to even show the kids as an educational standpoint, like how these systems work, which is why we kind of have these open ceiling panels or open ceiling to kind of show the ductwork. Not only that, the electrical work, it kind of brings in the whole educational purpose of kind of visualizing where the electric from the solar rays are coming from, where they're being stored and how they're being used daily. So that was definitely a consideration. And then I think we kind of just started off right away from saying we're off the grid completely, so let's find and create ways to utilize the solar advantage that we have of this property.
Yeah, no, I appreciate that. And then a quick additional question, just what's the climate in this region like as far as water, plant selections? Would you need to do any water catchment, or do they have available, potable water for the building?
Well, we definitely have water storage devices. In our occupant experience diagrams, we listed that we have rain barrel storage units on the rooftop to kind of use for the small kind of vegetation and gardens that we have. Climate-wise, I don't know if anyone checks in about rain and the weather. Like you said, it's kind of a moderate tropical.
Yeah, it's in terms of precipitation, it was similar to our climate here in Ohio. It wasn't absurdly dry or absurdly wet. It seems like rain was seasonal, so it was pretty moderate.
Awesome, thank you guys.
I don't know if I missed this in the discussion earlier in the paper. What's the what technology is the boiler? Is it just electrical resistance, or is it a heat pump boiler? What are you guys using for your boiler?
Oh yeah, we use a VAV HVAC system with hot water heat pumps.
It's just, I guess, a follow-up question to that. Curious how you arrived at that solution. I love the idea that, using this as an on-site learning experience for the students, and that's great. So I think you probably explored multiple HVAC strategies. So did you kind of consider a few, and then you just landed on that one for a particular reason?
Yeah, we kind of, like we said, this being a design competition, you kind of take some into consideration versus others. Like we said, maybe that this is a design strategy, so let's look at things that maybe are more expensive at this time, but can give a more beneficial output to not only energy storage, but a visual aspect, like we said to the students, is why we picked kind of, having these heat pumps and mechanical duct lines coming in on anchor bolts from the ceilings to kind of show where and how the heat is being produced and where it's being moved and the return valves and everything like that. So it was more of we ran a simulation and kind of did an analysis based on a couple different HVAC systems, but we found that the VAV heat pump would be the most beneficial for kind of the three areas of the building, while still being able to move air and having storage in the most efficient way, I would say, without taking kind of cost into consideration.
Great. Yeah, that's good to know. It's a good thought process to go through, and glad you went through that.
Thank you.
So does it work to have PV collectors above a soccer field?
We needed a net, so so soccer balls weren't flying off into the community, and it needed to be relatively tall. So in order to just kind of cap it off and really take advantage of that height, we decided to put a solar trellis on top of that.
But the collectors are protected underneath, right?
Yes.
Yes.
Yeah, they're safe.
Yeah.
Okay.
Is we wanted to both use the area, the square footage of the roof for energy collection, along with giving community access to it, so it, tied the building in with the community along with the rest of the design.
Right.
Is that soccer field like natural grass, a green roof, or is it artificial turf?
It's turf, yeah. It's just easier to maintain.
Sure. Okay.
Given some of the research y'all had to do, not being familiar with the area, do you feel the 12,000,007 is good for this size building and in that market?
So I think that we did kind of have a multiplier that we kind of added by to kind of ensure that our estimates were correct. And so that's basically yeah.
And we used like current US like data for this to find the estimate. So it might be different because Argentina is like an entirely different economy. But unfortunately, we weren't able to gather that like in depth of research. So instead we used our resources here and came up with a budget. If we transported that building into Ohio, how much would it be?
Right, and that didn't really include the amount of shortages or financial complications that's kind of occurring right now in construction. It's kind of more of a 2017 to 2018 type numbers with a more international multiplier with the amount of material and specialty, like we said, the brick veneer and everything, what something like that would cost to it. So we did the best we could, kind of taking the numbers that we do know while understanding there's problems and solutions, there's problems and different things that are going on in Argentina that we can't really account for. But yeah.
Got it. Thank you.
I know a couple of your line items here, brick and CMU says with install on your cost analysis, is the full 12.7 as installed, or is that not inclusive of labor?
I believe it's as installed. We did get these numbers from some of our supervisors from when we were on internships prior to coming back to school.
Correct.
And then you guys use Tesla battery packs. Are they available in Argentina?
Yeah, I'm pretty sure. They're even being sent to Ukraine right now, I believe.
Okay.
I really liked the AC versus DC analysis you guys did. Were you able to downsize your inverter and save some costs for some of that direct DC to DC, or how'd you kind of land on that?
That was just sort of an alternate we came up with as a way to potentially, have more energy savings in the project. It was sort of a more theoretical thing because it's incredibly hard to calculate all of that.
Right.
Given limited resources. So we didn't really go that in depth with it. That the energy saving number, which was 20% potential energy savings, or potentially you need 20% less energy generated to power the building. That was some very quick calculations based on estimates. So
Got it. Yeah. No, it's a good exercise to go through, especially with LED.
I'm curious about your EUI of 16. Sorry if I missed it, but is that before or after the PV?
That's before the PV panels. And then with the PV panels, it becomes a negative EUI because we have that excess production that is needed during times that we can't produce as much as we want.
I'd be curious if you like benchmarked and compared to see if that seems like, I mean, a lot of the projects today had pretty low EUIs, but just curious, did you benchmark against other similar buildings? Does that seem like achievable? Is it a good target for the climate for the area?
Yeah, we had some discussions with our professor, and originally we had some other calculations that were around 30 initial, and we really wanted to get it down to a 15 because that's what we kind of agreed that made sense for this area. I have taken a class in the past about benchmarking, so I draw on my knowledge from that.
That's great.
On where this kind of should be.
And for the overall energy usage portion of the EUI, it's incredibly hard to find data about Argentina, especially when none of us speak Spanish particularly fluently. So
I'm sure
we use sort of data from home, from America, and use that as just sort of an estimate based on school buildings of a similar size. And we got the EUI about where they are in average around here. So
yeah, benchmarking is always a really important first step. So it's good that you did that.
Well, fantastic. Well, that's our 15 minutes. So thank you, jurors, for the great questions. Students from the University of Cincinnati, excuse me. Great job. Another round of applause for you guys.
Thank you.
So we appreciate you guys joining us. Next up, we have our team from the University of Mexico. They are going to be here. Yep, they are here, which is great. So a few minutes of transition time, and then we will start our next presentation.
Thanks again.
Thank you.
Thank you.
So kindergarten and public space intervention in the marginalized area of Mexico City. So according to the UNESCO, there's an urgent need to invest in children's education, especially in those with disadvantage. So we're this team from Mexico's University of architects, undergraduate, and engineering students with the help of PhD Professor Carlos Romo. And also we'll have some introduction of the design program again, some strategies and some conclusions, and the replicability and potential of this project.
So we are located on the design classification 4A. And Mexico City has suffered an important transformation along the years. It passed from being a lake to being a mega city that in 2015 will be fully urbanized. Chinchorro is one of the few places where the Lake of Mexico still remains have an important tradition related to the environment. However, it has suffered high environmental degradation due to the urban sprawl, affecting the communities that live there and the ecosystem of the environment.
This project, we wonder how can we reconnect this place with nature and involve children in the process. And this is how Water Trail School is about. It's not just kindergarten, but revitalization of the ecosystem. So our main users are the children of the agricultural producers and we aim to use the 12 principles of agriculture to set our goals according also with the soil capital contests. And this with the three key elements we're going to use forward is water, energy, and landscape. So we're going to talk about that.
Yeah, so to find a plot, we choose some place that wasn't in the natural conservation area, that has a high or middle level of marginalization, a high population of children, and a lack of public space. From 5 main plots, we choose the one that has the largest area of water to have a better relationship with water landscape. So we have a community intervention and a public space intervention, and the biodiversity guidelines.
Yeah, with water, we want to clean water with water wetlands, and also harvest rainwater. And it also helps with avoiding flood in the area. So the next one, this is interesting because we want to decentralize the production of energy, involving the children with plays that they let them be part of this process. Also, we have the systems micro.
Talking about landscape, we use strategies that is cultivation, traditional cultivation support, and urban gardens that children can at homes. We base on the annual cycle of Mexico Newton, and each value has a different speciality in place of different varieties of year, has informed the combination in the spring to the relationship with rainy season of the water classes, cultivation, and the harvesting of food, and the relationship with the traditions of the seeds.
So this ecosystem-based design takes into account first the pedestrian flows and fluvial transportation flows, also at the site, also the wind flows that we will, the water of the lake that will be using in the water trail, and also the wind flows will be rejected in the cool season and embraced in the hot season, summer and spring. Radiation is considered to find the roof, so we can get the more radiation input into the system.
And about architecture, we look for movement and sensory activities for the children that are going to have the moving. Their main access is oriented at south, related with a public space, near the park as a environment. Their classrooms are north-south oriented to maximize daylight, natural daylight. And the playground are related directly with the crops and the generation of energy for play. Also, the habitable growth helps the children to come nearer to the crop of the trees to harvest some fruits and also be involved in the production of the children and the orchids.
So, in this building performance, taking into account these two main seasons, we want to make sure with this simulation that by 1 we achieve cross ventilation in the building. And also we have this RVI system to reduce humidity.
For optimizing daylight, we will also use sun shields and sun shades that are movable and the children will interact with them in case they want to do some like sleep, study, or play outside. And this helps to reduce glare. And because all the buildings have a different orientation, we the process where we design each shape depending on the values. Also, artificial light is optimized. We use the energy consumption through sensors and beamers, and we use a traditional system that is the high gate that is composed of soil, bamboo, and wood that has a big R value and helps us to reduce the heat transfer in the building.
Yeah, our suppliers started making miles, right? And this helps us to have half of the environmental impacts that traditional businesses. We have an EMI of 12, and this decentralized energy source lets us to send this forward. So, also the cost of this rate will be 40% of the average traditional scope. And this system allows also the community to be part of the conservation of the public space.
So its outputs, we obtain energy, water, and food production for the project to serve as an emergency collection center in case of disaster. And also the methodology could be replicated in similar projects near the waterways to create a filtration system along the area and increase the biodiversity of the zone. Water to School is a project that looks forward to reduce the disadvantage of the children, having them practicing with nature, and had a strong purpose in their community.
Thank you so much, Wesley.
Great job, guys. Thank you. Wonderful presentation. Okay. To our jurors now, we've got 15 minutes of Q&A. And feel free if you need to go back slides. I know you have a lot of slides, so it could be hard, but if you need to, feel free to do that. To my four jurors, let's go ahead and open up.
Just to start with, your renders and your design have been fantastic to look at. It's been, yeah, definitely pleasant.
I have a real quick question. It looked like you had a water turbine. So it looked like the site was pretty flat. How did you get the head necessary to run that?
Yeah, actually, the plot has a big area, so the natural topography goes 3 meters from the top to bottom side. So we have a flat head, and also we go under earth 2 meters, so we have a head of 5 meters in order to by gravity enter the water and then go out again to the.
Would that
Okay.
be a new canal system or is that existing?
It's an existing canal, but we are redirecting the water from the existing canal and returning to the natural flow.
I like the interactive energy generation. I think that's a lot of fun. Would you guys, would there be any kind of like dashboard or real-time demonstration of how much kind of they're making compared to usage?
Yeah, we wanted to demonstrate that in the graphics, but but yeah, like that's a like this dashboard, not just the only generation, but also with the irrigation of crops. Like children have this kind of
Like a steering wheel, yeah.
They can help irrigate the crops with the stats of the.
Like they can open up the canal and yeah, cool. Awesome.
How do you think the kids would like being the energy generation for the project? Do you think they view that as a positive or?
Yeah, we think that it was important for us to demonstrate that all kind of movement could generate energy. And it's not something that you only see and it's outside of you, but you can be part of it. And making children at that age be part of energy generation is really important for us.
That's great. Yeah. Yeah. And I just want to commend you. I feel like you wrote in your narrative and also in your presentation that you're focusing on 3 areas: energy, water, and landscape. But I also feel like you did really well in the other areas of IQ and comfort and ventilation. Those studies were really thorough as well. So, so that was great to see. The only question I had about daylight was I noticed that you had an SDA of 100%, which I said to another group earlier, I'd be very surprised. So I would just caution on that and maybe look a little bit closer into that. There is a shade algorithm that needs to be taken into account for that metric, but I do like the system that you've selected, that it's movable. That's the ideal, I think, anywhere. So yeah.
I'm not familiar with Mexico City. Is there one kind of school district organization or is it all through the city? And I asked because I like the replicability and the scalability. We do sister schools all the time. I didn't know if like, would that be able to be utilized by the education organization of the area?
Yeah, we have like a public secretary that organizes the schools.
Okay.
And so they look for lack of public schools and decide where the schools.
I got it. And they could take this design and that's great. Like it.
Do you think they will?
Also, because also there are some agenda with the organizations in searching for also system, because this is as we said presentation like polluted with irregular sermons, but yeah, they are kind of trying to do so also.
think all the passive features are really good too. And obviously the solar and the hydro are great. Are you guys able to feed into the grid too, or will you just need to produce what's there and use what you produce?
Yeah, we produce the play energy goes to crops, like it's a little energy, so it's for the landscape. And water, the hydropower is for the blocks and lights, and the solar we use some for the building and sleep is going to grid.
Okay.
Did you have battery storage?
And yeah, we have battery for 3 days. In case of a disaster, we have.
I guess one question I have is, you noted that one of your goals was LEED Platinum, which is great, but it's a very lofty goal to hit. And so I was curious in your linking that with your life cycle analysis, just curious, I saw that you did an analysis using Tally and that you had great graphics and talked about it, but I was just curious, like, did you think about what in the LEED credit, how you perform there?
Extremely vigorous analysis, but we have a lot of insight and energy and water management. So we are here.
Your windows that have aerogel fill, that's a really novel technology. It's definitely not traditionally market ready yet. Are you guys manufacturing those yourselves? Do you have a supplier already? And then have you considered all the kind of daylighting the aspects that aerogel can affect? What's the haze? What's the transparency, et cetera?
Yeah, we don't have the- or the windows, but we use aerogel because it was the one that has the lowest heat warming effect. So we look forward to not contaminate or not to do that. So it's going to be exciting.
Okay. Did you do like literature study or
Yeah.
look for other projects that have used it in the past or?
Yeah, we have some that could answer.
Are they on?
you there?
Yeah. Who is it? Is it Carlo?
Carol Castañeda, are you here?
Yeah. Carol.
Yeah.
Carol. Can you hear us? You're muted if you're trying to answer.
Yes, I'm here. Can you hear me?
Yes.
Okay.
You might want to repeat, our question.
The aerogel encapsulated in the window panes is a very unique, very amazing technology. Have you taken into account all the effects it'll have on the daylight and the lighting quality? Just looking at transparency, haze, those kinds of metrics for aerogel. How clear is it?
Carol, you're muted again.
And then also, have you done any literature reviews, have you found any other projects that have used this technology?
Carol, you're still muted.
Okay.
Okay.
Okay. I guess I'm more interested to find out about other projects that are using it out of curiosity myself. So
I've heard of aerogel as insulation, but I missed that in the.
Mhm. So yeah, that's very novel. Well done.
I have one more question.
Yeah, we still have
Do
about
we
5 minutes.
Oh,
Yeah.
oh, great. Yeah, so I was just curious about the resilience piece. So you noted that the area is a multi-risk zone. So I was just curious, like, seems like there's a lot of opportunity there to integrate into your design. So I was curious what, what resilience hazards, natural resilience hazards you saw in the area and how you put them into your design.
There are lots.
Yeah.
Firstly, actually, Mexico City is very, we also have this traditional. The nations of. And yeah, with the fluids also. Because there's a problem with drainage of the city, and when it rains a lot, it doesn't. So for the water flow and the kind of amount of treatment that you guys will be able to do on site, was that volume, all of that going through the hydro, or was there other water? Okay. Mhm. Yeah. Right. And they're designed for a 25-year storm or some amount of potential water, the bioswales.
Yeah, they are designed for the worst case scenario and analyzing the 20 years.
20 years. Yeah. Cool. Nice.
One last question for me. How did you come up with the 32 tons of CO2 captured?
The landscape aspect, and so are based so they promote the countries and plants.
Okay. Can be used also for, another and like and it start growing again.
Fantastic. Do we have any other questions from our jurors, or Rick, do you have anything else?
No, I'm good. Thanks.
Okay. Well, fantastic. Well, thank you guys. Another round of applause. Very well done. We actually have a break right now. Our next team, it will be from Ryerson University that starts at 4:40 p.m. Eastern time, 2:40 p.m. this time. So we got about 20 minutes. For any of our team from Ryerson who are all virtual, if you're on, I'll begin talking to you here in a few minutes to get us all set up. Everyone else, take a quick break. Thank you, guys.
Thank you.
Sorry. Thank you. Great job. Great job, guys.
So we got 2 left.
You want the clicker? You want to?
Oh, just see the thing?
Yeah.
Oh, yeah.
Let's see. I think they're on the first slide. Okay. Let me go back to the start and make it faster.
So they
You can come around.
thank you. That's what
So it is a triple P with the inside. That's why I was.
you just did. So I was off by like decimal days. So maybe I did notice that.
Still have about 7 minutes until our next presentation. Is that correct? Okay, 7 minutes for those who can hear us. I know there's some background noise in the main room here at NREL. To our team from Ryerson who's up next, if you guys are on, can you please start turning your cameras and mics on so we can begin our audio video check?
Hi, can you hear me?
Yes, Pooja, we can hear you.
Perfect.
Can you hear
Hi,
us
can you
okay?
hear me?
Oh, yes, we can hear you as well. Fantastic. Who was that? Sorry, just
That's Fionn, my
Gotcha.
Dr. Yang, yeah.
excellent. We're trying to get your guys' Zoom cameras pinned up. Oh, there we are. Cool. Got 3 of you guys. That's good. Okay. And you guys can hear us okay? I know there's background noise, but you can hear me decently.
Yeah.
Okay. Okay. Let's see. I've got your slides pulled up. Whoever is wanting to control them, you can go ahead and request control from your Zoom. I see it. Excellent work. I'm going to approve it.
Right.
And then once that goes through, you may have to click your mouse back into the Zoom window, but then you should be able to advance using the arrow keys.
I don't think I can control it right now. I'm trying to click on the Zoom screen. Is that what you're trying to?
Yeah. Let me see. So according to me, you have control. I'm seeing the mouse. Can you try to use your arrow keys? They're working. Okay, whatever you did worked. Okay, great. All right, that's working. Let's see. We still have about 5 more minutes. So do you guys have any questions?
I believe we have 2 more presenters that haven't been pinned yet.
Okay. Let's see. What are the 2 additional presenters? Because what are their names? We can see if we can see them on Zoom.
Nolene and Krishna.
Krishna and, okay, we're looking just to see. Well, we still have 5 minutes, so hang tight. And I will again make my usual formal announcement and everything, introducing you guys before we turn it over. We'll start your 8-minute clock as soon as you guys are talking. Did we find him?
I have everybody, but my computer resolution, they're not gonna all for what they're saying.
So you can max out with 6 spotlights probably?
Yeah.
Did you spotlight all of them though?
Yeah.
So what should happen is if they're talking, they should replace, I hope. In about 3 minutes and I'll try to wrangle all the people here in this room. So just hang tight.
Huge tree. Even one is very. I haven't been there, so. What they do is they get the ladder up, just the temperature set point at the RTU on the roof, and then 6 months later, they go and adjust it back down. And so it's never optimized ever again. It's just such a complicated.
But is that because system advanced?
I think I would actually. So they just didn't train facilities to handle this. Or the only person was trained in the district left and nobody got trained after.
Oh, I was recording this. I had started pausing. I forgot. Oh, well, I recorded the break. Yeah. Oh, well.
Make the editors work for it.
It's too many. I got too many things going. Too many multitasking things.
I'm just actually figuring out how to do that. Whatever.
Oh, I don't know what it does. Yeah, just convert stuff. All right. I think what I'll do to get everybody calmed down, I'll go up there to kick us off just to get everybody reconvened, and then I'll come back there.
The presentation was, I mean, I didn't see that. Like, I could say beautiful. Very colorful.
Okay, Education Building Division, we're going to be starting our last two presentations here in about 2 minutes. So those that are here, work towards your seats. And I'll come around and talk to my team from Ryerson from my chair over there.
Picking up their snacks on the third floor.
Right.
How's your day going?
Good. How's yours?
Great.
This is great.
Yeah, it's fun. 2 left, I guess.
2 left, all right. I think you guys should definitely do your practice
I was going to
room.
ask you, I don't know where that is.
You should go to X200, which is this little random conference room on the other side of the little cafe here. Yeah. And then yeah.
Okay.
So,
That sounds good.
okay.
Sounds good to us.
All right.
We just got, Stacy's over there chatting up jurors, so she's like.
So we're solving problems
She's,
over there.
sticking her head over there. What is this? I know, I finally caught up. I finally caught up. It's more our 14 from Ryerson. They're nervous.
Yes, they are.
And they can hear me talking about them too. So.
Hey, Ryerson.
Can they see me?
Yep.
They can't see you, but they can hear you. Oh, if you go over there.
Yeah, there you are.
Hi. We miss you guys. Hope you're doing well. Good luck. See, I got a smile.
I know. I know. Here. Oh, it's off.
No, just hit the
No,
like
it's-
power again.
No,
No, we
the
have
power, it's unplugged because it doesn't stop spin.
Oh, that's a bad one. Yeah. Oh, we can get you.
We'll do it now. Sorry, Ryerson. Well, a couple of our jurors are chatting with Stacy over there.
Sorry.
It's just taking a while.
Breaking the rules.
But don't worry, it's not cutting into your time.
Yeah, that's interesting.
We've all been here for a long day, so you know.
Yeah.
We are reconvening and sitting here. So let me welcome everyone back that is on or that's joining us virtually. We have 2 more presentations today for our Education Building Division. First up is our team from Ryerson here. Okay, Team Ryerson, let's just do one more check that you still have control over the slides. Excellent, great. Okay, so as a friendly reminder, you have 8 minutes for your presentation. We will give you a virtual cue, which will show up. I'll do it right now. Right there, when you have 2 minutes, should show up on your Zoom screen, and then I will pause. I'll stop you if we get to the 8-minute mark. Followed by that, you'll have 15 minutes of open Q&A with our 4 jurors. We have 3 of them here, and we have 1. Rick is joining us virtually. And so before I turn it over, Rick, let me just confirm that you're here and ready to go.
I'm here.
Does that mean you're not ready to go? I'm just kidding. Thank you, Rick. Okay. All right. That's my announcement to kick us off again. So Ryerson University, I'm going to hand it over to you. And as soon as you begin, we'll start your clock. So Good luck and take it away.
We are Team Reform from Ryerson University in Toronto, Canada, and we will be presenting our retrofit design for Gateway Public School in this year's Solar Decathlon competition. To introduce the team, our faculty leads include Kevin Stelzer and Yash Viaz. Our student team includes Chang Krishna, Nolene, myself, Pooja, and Yang. Gateway Public School is a two-story building located in the vibrant neighborhood of Flemington Park that exemplifies Toronto's multicultural character. Through our redesign, we ensured that we are preserving the heritage status of the building. We made sure that changes made have a positive impact towards occupants, and we've considered the cold climate conditions with reference to building standards and codes. The school was built in 1966 and is a prime candidate to undergo a retrofit that will enable it to become regenerative, affordable, resilient, and resource conservative to better serve its staff, its students, staff, and community.
We focus on optimizing the existing building by doing a deep dive of the existing spaces and surroundings. Through this, we improved accessibility and landscaping, among other elements. The architecture goal aims to enhance comfort of the occupant along with occupant experience, in addition to reducing operational costs through the implementation of optimized active and passive systems. The architectural design aims to respect the heritage value of the school while enhancing spaces interaction between students, staff, and the community. The use of wood throughout the school expresses natural materiality. The direct contact with light, air, plants, and natural landscapes is emphasized in the design to increase physical health, performance, productivity, and reduce stress of the occupants. Designed with different sizes, the modular system in the front entrance offers seating, planting, and resting spaces. In addition, these modular systems are elevated in different heights to provide different functions such as shading and seating. The courtyard opens out at the first floor level onto a green landscape that breaks the overall linear mass into a series of curvaceous spaces. The courtyard consists of three main spaces: children's play zones, terrace seating, and outdoor gardens. The terrace seating with curved edges provides a place for users to relax and an opportunity to socialize.
The current enclosure systems are failing. Retrofits of the envelope from the interior help to maintain the building's heritage value. Thermal resistance for assemblies meet passive house standards, and implementations are made to achieve target SI values as denoted by the Zero Emissions Building Exchange. We will replace the roof insulation and the parapet has the roof parapet has insulation wrapped around it to help mitigate thermal bridging. Options to insulate the slab on grade were regarded, but it was chosen to insulate the foundation with an insulated XPS skirt and insert instead. The new window system uses a certified passive house component manufactured within Canada, along with a triple glaze system with low E coating and air argon mix fill. With regard to the Ontario Building Code Act, rainwater harvesting will be incorporated to supply water to toilets, urinals, and excess water will be diverted to bioswales. This system uses a 17,600 gallon cistern on the ground level and allows for community learning. Low flow water efficient features tied with gray water further provides a 50% reduction in water usage.
The new HVAC equipment is a variant refrigerant flow heat pump system connected to a geo-exchange and terminal zone fan coils. The geo-exchange draws heat from 450 feet underground that is transferred into the VRF, then converts into supply air demand for the terminal zone fan coils.
The school currently has 506 PV panels of 255 watts. The building's unique composition allowed us to incorporate 1,192 panels of 480 watts to generate over 2 million kilobTUs of electricity per year. The oscilloscope was used to model the system with consideration to the building's different roof heights, shading, orientation, and climate conditions.
The goal of the design is to retrofit the school to operate as a net zero energy building, generating equal or more clean energy on the project site than is used over the course of a year. The baseline energy model was developed using Open Studio and Energy Plus to help guide the team by facilitating design decisions. The baseline site EUI is 109 kBtu per square foot per year, and the simulation results of the baseline consumption per end use indicated that space heating, interior lighting, and equipment use the most energy in this building and therefore are areas that were prioritized. Achieving net zero for this building requires ultra high levels of energy saving strategies to be implemented. We went through an iterative process to determine the best route to achieve our goal, and it took a combination of multiple measures to get to that point. Ultimately, the implementation of these energy efficient systems led us to a net positive building. We reduced the energy consumption by 84%, generating 4% more energy than the building requires.
Achieving quality, comfort, and maintaining healthy conditions for students and staff is vital. All existing materials that are hazardous to occupant health will be removed. In addition to passive strategies, there are thermostats for each occupied room for independent controls. More efficient ventilation, exchanging exhausted air with clean air. In terms of embodied carbon, the existing structure is preserved, greatly reducing the carbon footprint from demolition. Using one-click LCA, only the new materials added to this project are accounted for in carbon. As a result of sourcing locally produced materials that are very low in global warming potential, the overall GWP score is significantly low compared to projects of similar footprint and typology. The building's envelope is enhanced for building code approved fire resistance rating, significant thermal resistance, and prevents moisture and freeze-thaw damage to the assemblies. Also, guides are posted throughout the school to safely direct occupants to the nearest exit during a fire. The overall project cost for this retrofit is $12.3 million. The three major sums of the construction costs come from the building envelope, mechanical, and electrical systems. With the proposed design, operational costs are $77,000 annually. This is nearly 60% reduction from the baseline cost. By dividing the premium capital cost by the annual savings, the payback period would be less than 35 years.
The redesigns incorporate organic natural elements that appeal to the occupant's senses and comfort. Both the interior and exterior spaces integrate living plants composed of organic materials. Above all, the redesigns create a rich biophilic design palette that promotes the well-being of the occupants. Solera product has the advantage of transforming sunlight required with high light diffusing power. Diffuse daylight and optimized window to wall ratio are used to maximize daylighting, reduce glare, and to help improve occupants' performance. Dim light controls and efficient fixtures are also used to improve energy efficiency and reduce energy consumption.
By taking on an existing building, we were able to not only achieve optimal performance, but also integrated passive and active design. In addition, we used technical resources at hand and emphasized biophilia and landscape design. Again, we are Team Reform from Ryerson University. Thank you for your time and consideration for the Educational Building Division of the 2022 Solar Decathlon competition.
Thank you, Team Ryerson, and thank you for accommodating us, removing one of the cameras and trying to get all of your cameras up on our screen. And then I had to give a non-digital 2-minute warning, but you guys did great. So wasn't an issue at all. So great work. Okay, jurors, we have our 15-minute Q&A. You guys are also welcome to keep control over the slides and navigate back to them as you wish. So yeah, with that, I'll turn it over to my jurors.
Great. Thank you. It was a great presentation, very thorough analyses. So really enjoyed reading through that, and your presentation matched that. And the biggest thing from my perspective from an existing building is the hydrothermal performance. So I was really happy to see that was immediately addressed and that you really looked at that thoroughly. I was curious, and I also wanted to acknowledge you noted that you were not able to pull a brick sample, but that is the right process. So I commend you on acknowledging that, although on real projects do try to push that because you can always get a brick sample. So I was curious though, you looked at the freeze thaw and that's a really important criteria, but did you look at the other hydrothermal performance criteria like mold growth and where the dew point is in the wall and water content buildup or anything related to other hydrothermal issues?
Yeah, so when we did the hydrothermal analysis, we did it using WUFI Pro 6.0, and we were able to check other factors such as adequate drying of the building materials. We also made sure that we didn't just check the proposed wall assemblies. We made sure that we also first started with the baseline, seeing if there were any issues that were currently within the baseline to make sure that they wouldn't go into our proposed model.
That's great. Thank you.
I have a
Rick, I believe you're on mute.
Yeah. So anyway, on your description, it said it was VRF with ground source heat pumps. And then on your diagram, it looked like it was water source heat pump. Which one is it? And how did you provide ventilation?
So it's both. It's a geo-exchange with a VRF system. So they transfer the heat and they transfer the heat using the manifold there in the diagram in this picture. And the VRF turns it into supply air demand for like the different spaces.
Right. Okay. But how is ventilation? Do you have ERVs or what were you proposing?
Yeah, we do. Okay. We do have ERVs.
Okay.
We have, to be clear, it's a DOAS. It's a separate ventilation system with a DOAS and ERB.
Okay.
And where's the proposed siting for your geothermal system?
Good question. The geo exchange is located on the north side of the field of the school. So it is sectioned off on that side, away from occupant disturbance, not near the tarmac or any of that. We have the space to do it, so we used it.
Okay. I was glad to see you guys used one-click LCA and you got such a low score. One item you mentioned in here was that you made a decision to focus on the lowest GWP materials one-click LCA has in the database. Is that actually accurate of the materials that you think you would end up using? And then is that accurate in your cost analysis as well?
Likely so, it would be those materials, because when I was using one-click LCA for this, I was using them relatively close in terms of location to our site. So it was within the same province, Ontario, and in the same country. So that's also less transportation, local manufacturers, and which products were low GWP sort of like recognized. So it does also relate to the cost analysis, yes.
Okay, thank you.
You guys had a pretty good reduction in plumbing fixture water use, which is great. Did you consider impacts to existing sewer from that reduction? Design flows can get a little messed up when you have existing sewer receiving quite a bit less water on an annual basis.
So when we did our water management analysis, specifically more towards the rainwater harvesting design, we did use a costing tool by the Sustainable Technology Evaluation Program made specifically for regions within the Greater Toronto Area. It did look at other factors such as the cost of everything and the water usage and even like the roof materials, but looking at the impact of the sewers wasn't one specific thing that we considered, but considering the case studies and the research that we did, we considered that we looked at different case studies and the impact towards the sewers wasn't something that was brought up within the case studies, such as like the Billfish Forest Stewardship and Educational Center, which is a living building certified building that also used a similar system.
Okay, thank you.
I really wanted to commend you on your energy performance piece. I feel like it was really thorough. You went through all the steps that that I would go through if I were doing an analysis. I liked the iterative way that you looked at the ECMs and how you laid them out and the graphics for that. One question, this might be a hard one, but just curious if you looked at, you said that you're going with triple pane glazing, and there is, since you did an operational and an embodied carbon analysis, I was just curious if you happen to look at the weighing the two of those, because sometimes for triple pane, it's beneficial for operational, but not enough from an embodied carbon standpoint because you're using more materials. So just curious if you thought about that.
Sorry, are you asking about the embodied carbon part or energy?
About both, comparing so when you have triple pane, you're, it's obviously good on your operational, but then you're using more materials. So just curious if you thought about the balance between the two, like what your driver in design was, like if it's operational or embodied carbon, or if you just decided triple pane was good.
Right. In terms of the energy use, Chang, if you can go to the next slide. The windows did provide a beneficial like savings for energy, but in terms of embodied carbon, I think that question should be directed to Krishna for the windows.
For the embodied carbon of the windows, that is also a very good question. I actually was also like kind of discussing this like with another person about the windows. We focused more so for the windows in terms of the thermal resistance more so than like the embodied carbon for this. I understand your question, and the thing is we focus more just based on mostly the assembly, like reducing the operational costs and like the thermal bridging and such like that. So
I do want to, sorry. Okay, go ahead.
A little bit on top of that is when we doing the one-click LCA, Krishna was trying to find the local materials. So transportation-wise, it's also reduced embodied carbon, and also if we try to use the recycled content for the aluminum frame, so that's also reduced the embodied carbon a little bit. But yes, we do focus on the operational energy first, but can also consider try to reduce the embodied carbon in other A1 to A3 stages as well.
Great, thank you. Yeah.
I do want to add that of the envelope, the windows had the most savings, like in terms of the operational energy compared to the walls and the roof. So
you felt that was a bigger, benefit. Yeah, that makes sense. Yeah, I just think as embodied carbon gets bigger and bigger, people do more analysis. You obviously did thorough analysis in both, so just thought it was worth asking. Yeah. Great, thank you.
Thank you.
We still have about 5 minutes of available Q&A time if there are additional questions.
I'm curious, going back to the hydrothermal and thermal performance, whether you looked at the different like insulation types and how you decided on your wall assembly.
Yes, so I can answer that. So we did look at different insulation types. I know that we concluded with spray foam closed cell insulation. We were also looking at like rock wool comfort board, which was recommended by Passive House, and also polyisocyanurate insulation. We decided to go with spray foam closed cell insulation with reference to the hydrothermal study done on a masonry building in a cold climate by some of our professors and their colleagues. We found it to be very insightful, and that's one of the reasons why we decided to go with that. In addition to this, we also looked at different properties of these materials, considering like thermal resistance, thickness, density, conductivity, specific heat. We wanted to make sure, like for insulation, we wanted to make sure like how thick would it be? Would it make the classrooms a lot more smaller? Like also hydrothermal wise, making sure that there is adequate drying, and yeah, factors like that.
Yeah, that's great. That's exactly right. So yeah, there is a higher environmental impact of the closed cell, but there's differences in the performance. So it's good you looked at that.
About 3.5 more minutes. Doesn't mean we have to use the whole time. So Rick, do you have any additional questions?
No, I'm good. It was a good presentation. Very good. I like it.
Thank you, Rick. And to my jurors here, any additional questions coming to mind? Nope.
I would ask a little about the daylight.
Okay. One
so
more.
I was curious about, you said that it's not an ideal orientation for daylight, but I was curious how you dealt with that. And I guess the secondary question or thought was, you said you use translucent glass, but I would caution a little bit with it just at vision surfaces. It can create a really bright surface. So just curious your daylight concepts.
So when we first started designing, we focus our concept on biophilia and the benefits of daylighting to the occupant's health and performance. And we explored a lot on Dr. Roger Ulrich's theories and about the benefits of daylighting and biophilic design. Because our building is of heritage values, the changes to the front entrance was very limited, but we took great advantage of the back of the school because it was an addition. So we could make changes to the cladding. So we optimized the window to wall ratio, and also the placement of the windows were carefully thought out to allow daylight to penetrate deeper into the space, and also avoid any likelihood of excessive brightness. And also we focus on the north and the south facade because the quality of daylight is better when we compare that to the daylight of the east and the west. Like we mentioned the presentation, to combat glare, we use window shading devices on the east and the west facade, and we use Solera units. The reason why we use that was because it has the ability to transform raw daylight into a very soft, gentle, and more practical daylight. And it also provides benefits of natural light without glare. Yeah, and it's also compatible with different sustainable building certification, including LEED and BREEAM.
And also it maintain the thermal comfort of high performance glazing as well.
Thanks.
Fantastic. Okay, well, let's wrap up the Q&A then. To our student team from Ryerson University, thank you again. Another round of applause, which might be loud because the room's full right now. So maybe it's louder on Zoom. I'm not really sure. Okay, thank you guys. You did a wonderful job. All right, we have one more presentation, and so we're going to have a few minutes here of transition. And Ball State, assuming you guys are here, come on up. Let's get you guys set up, and then we'll do our final round. See if hopefully I return. A few seconds here, and then we'll. Your chart, okay. Hopefully. Okay. Go back and forth there. Okay. What is your? Oh, okay. No, that's great. I was going to talk about please don't trip on chords and things. If we were going to do musical chairs, that's really what I was asking about. Okay. Do you guys have any other questions? We'll do a sound check. All right. Okay, I am back in front of my machine. Rick, we'd like to do a quick sound check with you. So our two speakers from Ball State are going to speak into the mic and let us know if you can hear both of them.
Okay.
Here, Rick, this is the first check.
Yeah, I can hear her.
Second speaker.
Yeah, so I'm good.
Okay, there you guys go. So yeah, you're fine. Okay, I think you guys have heard me say this enough, but I have to say it one more time. You have 8 minutes. You're here, so Amanda next to me will hold up her little 2-minute warning sign when we get there. Once our 8 minutes is up, we'll open it up for the 15 minutes of allowable Q&A, which your team members are also welcome to participate in the Q&A. So I'm glad they're up here. Let's see, with that, I have no reason to wait another minute. So I'll just say that the floor is yours. And when you're ready to start, well, let's just do one more check before make that. Okay, good. I'd like to check it one more time. I'm gonna sit down if I bump something, you never know. Okay, the floor is yours. We'll start your 8 minutes as soon as you begin.
Imagine an inner city school surrounded by a struggling economy, a fluctuating population, and a high number of students switching schools mid-year, resulting in reduced academic achievement and lower test scores. Now imagine over 1,700 students being uprooted, forced to find alternative educational opportunities outside of the comfort of their communities and their neighborhoods, leaving the school vacant with echoing halls, empty seats, and the only sounds coming from an occasional afternoon basketball practice. Though we wish this were rare, many of our nation's cities are facing this exact challenge today. We're Team Reconnect with Ball State University. For this year's Education Design Challenge, we found one of these struggling schools, and we're excited to show you our solution to revive the community asset of Thomas Howe High School. Howe High School sits on the east side of Indianapolis, Indiana, in Christian Park, which is adjacent to the Near East Side and Irvington neighborhoods. The school closed in 2018 due to poor academic performance, with both public and charter schools failing to bring grades up. When analyzing the area, we noted community resources such as existing schools, grocery stores, industry businesses, bus stops, and community connections. We really noticed, however, an excess of elementary schools and a major lack of public middle and high schools, leading us to redesign the curriculum to accommodate grades 7 through 12. Einstein once said that doing the same thing over and over and over, but expecting a different outcome is how we define insanity. So we've chosen to do something different and adapt the school to a vocational school focused on building trades. Within these 3 neighborhoods, we realized that occupations within natural resources, construction, and maintenance industries are proportionally lower than others. And with the average tradesperson currently being 55 years old, we can infer that in roughly 10 years, a large portion of these tradespeople will be retiring, leaving a large gap open, something a vocational school can help with. This vocational transformation, however, has presented a few extra costs with some of our unconventional spaces. Luckily, though, the existing building already consists of many large and costly spaces, such as 2 gymnasiums, an auditorium, a cafeteria and kitchen, and restrooms and vertical circulation that we've decided to keep and reuse, saving $86 million in construction and material costs.
A school is not just a building, but also the site that it sits on. With little green space in inner cities, we push to have a lively site so that students can enjoy nature. We added more trees for shading, green roofs, and a garden. We also utilized the site to help the school reach net zero by having the space under the ground source, having the space under the track with the spot for the ground source heat pump, and having 541 PV panels on our roof. Our heavy equipment and heavy construction storage, as well as the metal fabrication lab, is located on the southern part of our site across Cow Street in order to reduce space pollution. The space is also dedicated as an area for students to partake in our vegetable garden and greenhouse. We also reduce noise pollution in the lower level of the cafeteria by switching from a loud and noisy boiler system to a ground source heat pump, with its internal components being located in the first floor mechanical room. Thomas Howe High School was built in 1938, constructed with a traditional curriculum in mind, and paired with numerous additions throughout the year, leaves the school with a patchwork of spaces and an overall uncohesive layout. In order to have a better functioning layout for our new curriculum, we utilized the existing spaces and newly renovated classrooms, trade labs, and collaboration spaces, as well as denoting separate entrances for the middle school and high school students. With having this as a vocational school, we adapted the layout so that there were classrooms overlooking the trade labs so that younger students can learn about these building trades without overcrowding the space. Here you can see one of our construction labs, one of the many trades that would be offered at the school. These trade spaces allow for a connection between the classroom and lab, providing a direct visual between hands-on experience and traditional learning. All three levels, this one included, house general classrooms that create moments of the traditional double-loaded corridor and offer opportunities of access to our occupiable green roofs. This floor also includes a double height space that connects our media center to our grand entry, which we have redesigned. We've also designed collaboration spaces for the students to learn in environments that promote engagement and creativity. We have incorporated them throughout the school. The media center and the entry are not only connected vertically, but also through our large grand staircase. These spaces provide an environment for students to come together, students of any grade or trade route to come together and study and learn during their free periods. With the separate entrances for the middle school and high school students, the middle school students have a direct route to the third floor that houses the majority of their core curriculum classes, such as general math, science, and health classes. We also designed collaboration spaces so these students can learn in an environment that promotes engagement and creativity. We incorporated these informal and formal collaboration spaces throughout the school. Here, students and teachers alike can reserve a space to work on group projects, present their work, or even host class for a change of environment.
The existing and historic structure is comprised of multi-wide brick walls and steel columns, resulting in an R value of only 5.17. So we realized we needed to increase our insulation properties in order to mitigate interior temperature fluctuation. We've used a closed cell spray foam that incorporates all 4 control layers, giving us a new R value of 31.41. This in turn decreases our utility bills, decreases necessary maintenance, but it increases our occupant comfort. The current HVAC system runs as a steam-based boiler system, which is one of the most environmentally destructive. So we've chosen to replace it with a ground source heat pump that has many benefits, including less necessary maintenance, and it can also heat and cool different zones of the building at the same time, leading to a more comfortable learning and teaching environment. We paired this with a heat recovery ventilator that works during any season, but especially when it isn't feasible to utilize our operable windows. The team has been really intrigued with the difference in embodied carbon between reuse and building new, and we found that with a renovation, we decreased the embodied carbon usage by 85%. We also found that it takes over 50 years for the environmental impacts of a new net zero building to become justifiable. So with the school sitting vacant in our community, we found it the best fit for both the community and the environment to renovate Howe High School. And with water scarcity becoming a more pressing issue, we've developed plans for rainwater collection and gray water reuse. This, paired with our motion sensor faucets and our low flow fixtures, help us to use only the necessary amount of water, reducing consumption by 59.59% below baseline.
With our site sitting between 3 neighborhoods, we found it important that Howe High School not only be a school, but also a whole community asset. We achieved this by having a health clinic on the north side of the building and a disaster relief shelter in the gymnasium. During the day, as said previously, the school acts as a vocational prep school. During the evening, we have decided to open it up to the community so that adults can also learn about these building trades. Since the school will be open after hours, we designed a safety shutdown system that would shut down parts of the school in order to conserve energy. We also designed spaces throughout the school that would help the community in case of disaster. The cafeteria can be altered into a full-service kitchen and a food bank, and the gymnasium into the shelter. With the connecting locker rooms having showers, the shelter has a capability of supporting 215 people for long-term relief. Through these movements, the whole entire community can benefit from the revitalization of Howe High School. Our renovation of Howe High School creates a sustainable educational and community asset that can serve students in the community for years to come.
Good timing. Time up. Okay, thank you. Great job, guys. Great job. All right. Breathe. All right, great, really great job. Okay, we have 15 minutes of Q&A. You guys if you come up here, just please be very cautious not to come over here where you see all these wires. Just watch your feet. We've tried to take down as many trip hazards, but I do encourage you, feel free to wander up if you'd like. If you don't want to be on camera, you can stay right there and talk to the audience, it's fine. Project your voice a little bit though. These mics are the main ones that are also being broadcast as Zoom. So with that, jurors, it is your 15 minutes. Feel free to ask away.
Thank you for actually including where you're going to put your geothermal system in your plans. That is definitely nice to not have to figure out. Since you are doing a whole HVAC retrofit, I'm assuming there's no ductwork at all in the building right now, and so you'd be adding all this.
There is current ductwork. A lot of the ducts specifically have been renovated, and so we have the capability of using ducts if they're in good condition. And then we also plan to replace them. So it is a ducted system.
It is a ducted system now. Okay.
Real quick on the ground source heat system, how did you guys consider vertical, or did you? I know you kind of mentioned you went horizontal for the costs. Sometimes those can be, less effective over the long term.
So we chose to put it underneath the track because the track and the ball field are already pretty. So they need replaced, and we figured typically it's a lower cost option in order to do horizontal, and we have plenty of land on the school, and so we found the best fit and cost and energy to do that work.
You said that there was existing ductwork in there. What kind of system do they presently have, and when was that installed?
It's a steam-based boiler system, and it was implemented within the original building of Thomastown, so in 1930.
So you say it's what, steam radiators or something?
Yes.
What's the fuel source for the steam boiler? Is it oil, coal?
Yeah.
It is, okay.
So if it's steam based, what were the ducts? What were they used for?
There have been some additions throughout the years. So there's been added like HVAC systems. It's just not cohesive throughout the school.
That's fine.
A question about the embodied carbon analysis, obviously super important. When you have an existing building, you're saving a lot, like you noted. I was just curious about, you noted in one area that it was 9 times better, and then another area you said 85%. I was just curious, like.
That's based on just same numbers. So I'm just simplifying a little bit more, but in reality, it is
85% reduction from if you were to put in a new building.
Correct.
Okay, great, thanks. Also related to retrofits, hugely important hydrothermal performance of the wall. So just wondering if you looked at that piece of things when you're adding the interior insulation that's impacting the way the wall is working. So just wondering if you looked at that piece.
Yeah, so within that, so we've saved a lot of money and also energy on conserving the exterior structure. So that's about 80%. Masonry. And then we did have to implement more insulation on the interior because it was just the brick on the exterior.
Yeah, but you didn't perform like hydrothermal analysis to understand that. Okay. Yeah, I'd recommend it in the future.
Did you take into account the cost of replacing the track and field as well in your cost estimates?
We did not, because that wasn't like the most necessary thing to get kids back into the school. Because the school's unoccupied right now and it has been since 2018. So we're not focused on getting the track completely redone right away. Because I know budget for the school system is kind of tight. So just getting the school itself ready to go for students to get back in it, and then the track and football field would come at a later date if they don't have the funding for it right away. But it was not included in the initial process.
So you were, I think, one of the only submissions, maybe the only, to lay out the curriculum, which was great. And it's a good concept that you have to, fill in this gap that's clearly missing. I was just curious, non-technical question, but have you thought about the other like non-trade students that also would need to still compete further? Was there any consideration of that, of like other programs in school that could accommodate that, or is it just for trades?
So there's plenty of schools in the area, but there's still many like Indiana's 440 diploma. So any student coming through this program has the opportunity for this trade preparatory school, but then they're also still getting the standard high school diploma. So we were mainly offering this as another option as opposed to those basic schools.
I think you guys did a pretty nice job. We're kind of respecting the building that's there already and trying to keep it, as part of the community. I didn't know if you were able to do any kind of outreach or engagement to understand some of the components that you've discussed.
Yeah, sure. So we've been in contact with the chief operations manager of Indianapolis Public Schools, and he's given us great background into the area, and then also the and then we've also been looking at area plans to work our goals. So things like community connectivity, adult education, and alternative education as well.
Nice, thanks.
One other question about analysis related work. So you mentioned natural ventilation, and that's a strategy that you might want to pursue. Did you kind of do any background on that or figure out like if that would be beneficial or optimal in this climate?
So in our climate, it's we have a lot of extremes. So passive strategies aren't always ideal, I guess. But we do have operable windows that would help with that, especially in the street sides with like the higher spaces getting circulation of air. But it is a little bit more difficult to use that because we have such extreme windows.
That's right. So yeah, good to know. That's great.
Are you guys replacing windows?
Yes.
What are you putting in?
We are going to put in double pane windows.
And did you choose those over triple pane for cost, or didn't
Yeah,
see
that was double panes
benefit?
was kind of the middle ground for that instance. And so to kind of help alleviate some of the other cost components and stuff, double panes was what we chose.
Do you say the window new U value is 0.25? Is that right? 1.5. That's really low. I'd be surprised if you could find a double that's that low. So yeah.
For the solar, I don't know, I might have missed it. Did you guys do a full analysis of layout and azimuth orientation and those components?
Yeah, I think.
Yeah, so in the sun hours analysis, the school isn't, so north is, I guess, a little bit diagonal from here. And so the kind of mass at the bottom is our trade labs, and that is the southern kind of portion where we're having one of our solar panel arrays. And then so towards the north above what is the gym on that side is the second array, and between those arrays also facing south direction to absorb as much direct light, and then having the correct angle around 30-ish degrees to implement and kind of control that amount of input.
Thank you.
Still have 5 available minutes if there are additional questions from our jurors.
now that you've gone through this process? Is there anything you would do differently? Any other technologies you would choose that maybe you've learned about from meetings over the past few days or anything like that?
I think we did choose a very big school. So it's like 330. So this was challenging, just like drawing it, and just understanding everything. So I think if we would have done this all over, we would fix it.
What's the likelihood that they're going to do this renovation, either with your design or somebody else's?
Yeah. So right now it's just a proposal, but it does have the potential to be a project. So like I mentioned, we have been in contact with people from the Indianapolis public school system. And they liked our design and have talked about maybe implementing some of our strategies to influence designs for other ed schools. Especially the ground source heat pump. Yeah, especially the ground source heat pump. That's something that the COO said that he hasn't seen in Indiana, but it would be.
Rick, do you have any additional follow-on questions?
No, I'm good. Thanks. Good presentation. Thank you.
Thank you, Rick. To our other jurors, we still have a few minutes, but it doesn't mean we have to use them all, so. Are we good? Okay, well,
Yeah, thank you, guys.
one last round of applause then. Thank you, guys. I'll come up and make a quick announcement. All right, well, thank you to all of our student presenters, their teammates who were here to cheer them on and support them in the Q&A. Thank you to those that joined us virtually. That was our final presentation for this year's Education Building Division. So one last round of applause for all of our teams. So for students and participating in the other events going on, look at your UBA app. If you've downloaded that, it gives you detail about all the agenda and things going on. To those online, I'll be shutting down the Zoom meeting here in about 3 minutes as soon as I get back to my chair. So thank you again for participating. It's been a wonderful day, and we look forward to the presentation of the winners, which will happen tomorrow as part of tomorrow's festivities. So thank you. Rick, are you still there?
I am still here.
Okay. So what we're going to do here is we're going to move to a different meeting room so that we can do the deliberations. I'm going to send you, I will have to email you a new Zoom link to do that. So watch for an email from me. Let's give ourselves, is 15 minutes enough? Or do you want longer to my other jurors? Before we start deliberations, we can 15? Rick, is 15, if we take 15 and then reconvene, is that good for you?
That's fine. Is everybody going to be on Zoom or is it just me and?
So, well, I'll be on Zoom so that you and we can all interact. Our other 3 jurors will be in the rooms. They have laptops. We can see if we can make that work, and so you can see other faces and cameras as well.
That's right. Just so I can hear them.
Oh, yes, we will. We'll definitely be able to do that. We'll work that out here in the next 15 minutes.
Okay. I don't need to see faces and I don't.
Okay. Well, we'll make sure the audio is good. All right. So let's see. That's, sometime around 3:45, 3:50. We'll be starting up that other Zoom room. I'll send you the link.
Okay, great. Thanks.
Thank you, Rick. Thank you.
Well, they do like.
All right, so everyone else, I'm ending the meeting for now.